Page 762, number 29. Find the derivative of the function f, and f of x is 2 minus 3x. So it's going to be slightly different, the definition of the derivative we're going to use compared to number 23. So if you want to see the difference, you should look at that video, because now we're asked to find the derivative of the function so that we can use that derivative at any point, where in 23 it was for a very specific point, x equals 2. So the definition that we're going to use this time is the limit as h approaches 0 of f of x plus h minus f of x, and that's all over h. So this time we don't have a value to substitute in, because as I said, this is going to be for any value of x where the limit exists. So what we're going to do is we're going to substitute in for x here in the first part of our expression. We're going to substitute in x plus h and simplify that. So let's go ahead and do that. So we're going to have the limit as h approaches 0 of 2 minus 3, and here's where we substitute in x plus h. And then minus, and we're going to substitute the entire function of f of x, which is 2 minus 3x. And that's all over h. So, like all our other limits that we've done in this section, we're going to simplify that expression as much as we can. So we're going to have 2 minus, I'm going to distribute the 3x minus 3h, and then I'm going to distribute the negative sign, and I get minus 2 plus 3x. And that's all over h. Now, if we're doing this correctly, so the limit does exist, what we're going to find is that every term that does not have an h in the numerator should have an opposite term as well, so they cancel out. So what we're going to notice is that we have a positive 2 here and a minus 2, they'll cancel. We have a minus 3x and a positive 3x, they will cancel. And then we're going to be left with the limit as x approaches 0 of negative 3h over h, which is going to simplify to the limit as h approaches 0 of negative 3. And since that's a constant, the value of the derivative of the function is going to be a constant, which is negative 3. Now, that's because we started with a linear function. Many times, if we start with a quadratic or a trig function or an exponential function, our derivative will be a function, and you will see that in later problems.